In this video, we'll be going over cross-site request forgery, also known as CSRF. So CSRF, or cross-site request forgery, is a way for an attacker to make you do unwanted things, basically. In this particular example, we'll be changing the admin password to a value that the attacker wants as opposed to what you want. Now, why does CSRF work? CSRF works because of the way the internet works. There's an implicit trust between you and the server that you are sending requests to. And this can be seen through the request you send. So if you have your session cookie, in this case, PHP session, you are authenticated as that particular user. There is this implicit trust that you are who you say you are. Now, as long as you have the ability to link other websites on other websites, so essentially, Google linking to another completely different domain, there will be CSRF attacks. So let's see exactly what I mean by this. So on this particular piece of functionality, we can see that we can change our admin password. And there's new password and confirm password. So let's do that. So we're going to change it to test and confirm the new password as test. I'm going to change it. Password change. So let's look at that. And we can see that we have sent a GET request to vulnerability/CSRF, and we have parameters and values here. And we can see password new equals test, password confirm equals test, change equals change. Now, this is a GET request, which means that we could probably link this as a hyperlink text on another page. So that's exactly what we're going to do, actually. I have created a small little HTML page here. And you can see here, we have HTML, body, form, method equals get, so on and so forth. And the action here is go to this particular IP address, vulnerability, and we have our inputs. Password equals new, value equals test, password equals confirm, value equals test, and change equals change. And of course our submit button here, which we don't even need the submit button. We could write some JavaScript so that even if you land on this page, this request is immediately sent, like with no user interaction at all. But I wanted to show that you can do this even with user interaction. So pretend that this is a completely different application. This is a attacker-controlled application, and you are currently authenticated into DVWA in another tab, or not even another tab. You just have the cookies in your browser, and you hit this button, and what happens? You just send a request to DVWA with your session cookie, and you just changed your password. Now you can kind of see what the attack for this what an attack for cross-site request forgery might look like. Most commonly, these are used for password changes or using it to force an admin user to perform some action that they weren't aware that they were performing. Personally, I've seen this used to delete users, like an admin deleting a user that they were unbeknownst to. Using it to pose as someone else making a comment on something, so on and so forth. So this seems pretty broken. How do you fix this? Well, one, you don't have it as a GET request, so that all this information isn't in the URL. So actually, I'm going to send this over to Repeater so that you can see exactly what I mean. So let's change this to a post request first off. So the big problem with cross-site request forgery is an attacker knows the format of the request being sent. But we can change that. We can change the format. And in this case, we can change the format in a way to be random. So and lots of different frameworks for building web applications contain some form of CSRF protection. And most of the time, this is known as a CSRF token. And a CSRF token is just a random value, some random value that is generated either per request or per authentication. An attacker cannot guess. And if that token is not sent, then it is the request is invalid. It will not perform the action without this CSRF token. Another way that different applications will test against, will try to protect against CSRF is host header check. So a host header checker, basically to see whether or not the request came from on-site. This isn't always perfect because a host header header can be spoofed, but that doesn't necessarily mean that it's a terrible way to go about checking for CSRF vulnerabilities. But the CSRF token is the best form of protecting against this because it's a completely random value. Now, we want to test against, we want to know how to exploit this, right? So in this case, it was a GET request. I could just link the GET request. Same thing with a post request. If this was a post request, I could just throw it onto my website, and if someone happens to go to my website, that post request will be sent in the background. If there's a CSRF token, that makes my job a little harder. The big thing with CSRF tokens is, as a tester, as an attacker, you can try a few things. Try removing the CSRF token completely from the request. Does the application still accept the change? If so, then you don't need the CSRF token at all. What about the value for the CSRF token? Is it checking the actual value, or is it just checking for the presence of a value? If so, try putting a random value or an old CSRF token value in there. Or just throw in some garbage about the same length as what the original value is. Some CSRF token checkers are only checking for the actual length of the token, not actually what the token actually is. I hope this helps in your understanding of cross-site request forgery. If anyone still has any questions, I can make another video, maybe go into more detail about exactly how to go about exploiting this.